Hello friends, this is Kunal. Welcome back to MATLAB. Today we are going to make a circuit model in Simulink and see its responses. Today we are going to make a PID controller as a circuit model. So before starting to make a PID controller, I want to let you know what PID controller is. So there are many kind of controllers available. One of them are PID controller. It consists of proportional controller. This proportional controller simply increases the error signal. In this figure you can see there is an example of float and tank. Here the error signal is the difference between the set point and control point. As the level of the control point increases towards set point, the error gets decreased, and likewise the valve here gets closed. The next component of the controller is integral control. It simply increases the stability of the steady state. Now the last component of the controller is derivative control. It simply increases the stability of the transient region. Now open the MATLAB and open the Simulink. Here create a new model. Now under Simulink sources tab, we are selecting a source. Here I am selecting a step source. Now under sync tab, here choose scope. Now under continuous tab, a transfer function is selected. Now under mathematical operation tab, a summation block is selected. Now I am creating this model without using PID controller and see what is the difference between using the PID controller and without using it. Now change this summation block as plus minus because we are creating a closed loop transfer function as a negative feedback system. Now change the transfer function. I am changing the denominator here. Now the denominator is s square plus s plus 5. Now simulate this. Open up the scope. Now you can see there is more disturbance at the starting point, and as the signal increases it stables. Now make this model using the PID controller. Now to make PID controller we need some more additional blocks. Like here we need another summation block. We need here a derivative block, integrator block, and here we need 3 gains. We can simply copy and paste it here. Now we need a multiplexer to see multiple outputs under one scope. Now we are done. So we are controlling here the error signal. So connect the PID controller here. Now I am inserting a gain block for proportional controller. Here the derivative block and a integrator block along with their gains. Now connect these blocks with the error signal. And sum up the all signals from the controller. First we have to make it as 3-port device. Connect all the points and at last connect it with transfer function. Here connect the multiplexer block. I am connecting a pair with the output and another one to the input. Now finally connect it with scope. We can change the gain of the integrator block here. I am making it 10 and the derivative gain as 4. The proportional gain would be 14. Now to see what the integral block alone can do without using the derivative, I am disconnecting this wire. Now simulate it. Open up the scope. Now you can see there is more disturbance at the starting point, but as the signal increases it stables up. So the integral block is used for stability of the steady state. Now we are disconnecting this integral wire and connecting the derivative wire. Now simulate this. Now we can see there is less disturbance at starting point. So the derivative block is used for stability of the transient region. Now connect all the blocks with the summation block. Now see the response. So there is less disturbance at the starting point as well as in the steady state. Now I have simulated it many times and get the optimum value of the integral as 4. Proportional blocks gain is as 20 and derivative blocks gain is as 3. Now let us see the response. Now you can see there is less disturbance in the starting point and it reaches to the maximum value, and as the signal increases it reaches to steady state. Now you can see the disturbance here much more suppressed here. So in this video you have seen how to make a circuit model and see its responses. In my next video I will show you how to make Bode plots, Nyquist plots and see its responses in MATLAB. Thank you.